What if I told you that the secret to making an AI smarter wasn't feeding it more perfect information, but instead feeding it a bunch of noise? Yeah, it sounds completely backwards, I know, but some recent research has uncovered this fascinating, super counterintuitive quirk in how these models work. So let's dive into the surprising power of noise.
So let's just ask this straight up. Is more information always better for an AI? For decades, the assumption, especially in things like search engines, has been pretty simple. To get a better answer, you need more, higher quality information. It makes perfect sense. It's totally intuitive, and, as we're about to find out, it might just be wrong.
Okay, so to really get why this is so weird, we've got to talk about a huge problem with large language models. You've probably heard of it. They can hallucinate, and that's just a nice way of saying they totally make stuff up. The most popular solution to this is to basically give the AI an open book test every single time you ask it a question. And that's where this technique, called Retrieval Augmented Generation, or RAG for short, comes in. The whole idea is, instead of making the AI rely on whatever it memorized during training, you give it a library of relevant documents to look at right before it answers. It's literally like giving a student the textbook during an exam so they don't have to guess.
So, on the surface, the process is super simple, right? First, a retriever system goes out and finds documents related to your question. Then, the language model uses only those documents to figure out its answer. The common sense thinking here is that the better your retriever is, the more relevant stuff it finds, the better your final answer will be. But this is exactly where our story takes a very sharp turn.
Because what researchers found was a hidden danger just lurking in this process. The problem of information that is almost right, but isn't. The danger of close enough.
They gave these a name, distracting documents. These are bits of information that are topically, very similar to your question, but they don't actually have the answer. The paper has this great example. Imagine you ask about the color of Napoleon's horse, and the system pulls up a document about the color of his wife's horse. It's close, it's definitely related, and it's 100% wrong.
And wow, the effect is immediate, and it is dramatic. When the AI gets only the single correct document, its accuracy is high, just like you'd expect. But then you add just one of these distracting, close enough documents into the mix, and boom, the accuracy takes a serious nosedive. The model just gets confused.
And it's not just a small dip. It gets so much worse. As you keep adding more of these topically related but incorrect documents, the model's performance can absolutely plummet by as much as 67%. The very information that was supposed to help is now actively poisoning the well. So the big question is, why?
Well, this heat map basically lets us peek inside the AI's brain and see what it's paying attention to. The darker the blue, the more focus that document is getting. Now look over there on the left. Those distracting documents are sucking up almost all of the AI's attention. And now look all the way to the far right. That's the correct gold document, and it's almost completely ignored. The AI literally gets fixated on the wrong thing. Okay, so that's already pretty strange, but the problems don't stop there. Researchers found another, even weirder behavior. Turns out it's not just about what information you give the AI, but where you put it. They discovered that these AIs suffer from a bizarre lost-in-the-middle problem. If you put the correct piece of information right at the very end of the prompt, right next to the question, accuracy is highest. If you put it at the very beginning, it's a bit lower. But if you bury that single golden piece of information somewhere in the middle of a long list of documents, the AI is incredibly likely to just ignore it completely. All right, let's just recap for a second. We've established that closely related but incorrect information is bad, and we know that important information can get totally lost in the middle. This all leads to a truly wild question, and the single most surprising discovery of this entire study. Just think about that for a second. If documents that are similar to the topic actually hurt the AI's performance, what in the world would happen if you just threw in documents that have absolutely nothing to do with the question? What if you added pure random noise? The result is just shocking. Adding random, unrelated documents didn't just prevent the performance drop, it actually increased the AI's accuracy, and in some cases by up to 35%. I mean, this is the exact opposite of what anybody would ever expect. And just to prove how truly bonkers this is, the researchers pushed it to the absolute extreme. They found that this positive effect still worked even when the noise documents were just gibberish. We're talking nonsensical sentences made up of random words. The AI literally got smarter by reading junk. So let's just pause and put this side by side, because it is pretty mind-bending. You add documents that are topically similar but wrong, and the AI's performance tanks. But then, you add documents that are completely random and unrelated, and its performance gets better. This just completely flips our entire understanding of what it even means to help an AI find an answer.
Okay, so what on earth do we do with this information? Well, it means we have to completely rethink how we build the library that we give to an AI.
This all points to a really fascinating trade-off. The study suggests the best strategy isn't to just retrieve dozens of potentially relevant documents. That just increases your risk of pulling in those dangerous, distracting ones. No, instead, the best performance actually comes from retrieving just a few highly relevant documents, and then filling the rest of the AI's context window with random noise.
So at the end of the day, this research kind of changes the job description of the retriever system. Its goal is no longer just to be a librarian, finding every related book on the shelf. It needs to be more like a curator, carefully selecting a small amount of high-quality signal, and then, counterintuitively, surrounding it with a protective buffer of noise.
And this leaves us with one final, fascinating thought to chew on. This behavior is so deeply alien to how a human mind works. We thrive on context and relevance. But for these models, it seems like maybe, just maybe, a little bit of chaos, a little bit of noise, is the key to helping them focus on what truly matters.